So if this is A, and I'm interested in, that's the x value, and I'm interested in finding the y coordinate that goes with this. Hopefully you would recognize that that y coordinate would be, or that ordered pair, I guess, up there would be A, comma, f of A. Does that make sense to everyone? Okay. This ordered pair over here, because the x value was A plus h, so that ordered pair would be A plus h, comma, f of A plus h. Okay. Is that doable? Okay. So now, what's going on here is no matter where I move these things, A and A plus h, you see the secant line, that dotted line, kind of changes, right? Okay. So what we're going to do, what we would do algebraically in questions 11 and 12 in the assignment, is we would algebraically basically come up with a formula that allows us to find the net change or the average rate of change, either one of those things, for this secant line, regardless of where A and A plus h showed up, because they change all the time for this graph, right? Okay. Yeah, I'm not using that one right now. So when I move these things around, we've got a different secant line. So this is what I want to kind of think about as we're doing the algebra and realize what the algebra is telling us. Okay. If I just take, because I want to draw on this, and for some reason my smartboard won't draw on top of GeoGebra today. Okay, so if I've got that, what we're doing and what the net change, remember net change, let's see if I can lock that in place. I uninstalled Smart Notebook yesterday to see if that would fix my issues with it, and they got worse. Remember net, see what I mean? Seriously, that's not where I'm writing. All right, we'll do it this way. All right, so net change is equal to, just using some notation that maybe you've seen in a science course, we'll use, where's my Greek letters at? Where's delta? There she is. Delta y, right? You didn't know she was a lady? Okay, so Control V. All right, so net change is delta y. Okay? Well, delta y is simply the difference in my y values, right? Delta means change or difference. So in order to get the correct increase or decrease for net change, we need to make sure that we subtract them in the right order. Does that make sense? Because, you know, if this y value here is, will this thing work? Hold on a second. And I can't see where it's at. I'm sorry. You just want to quit for today? Yep. No. All right, let's say that y value there is 10. Okay. This y value up here would have to be greater than that, right? So let's say it was maybe 15. Okay. What order do I have to subtract those to get the correct slope here? 10 minus 15. I got to go to the point furthest to the right minus the point to the left, right? That's something we got to think about as we're doing these net changes, because I could do 10 minus 15 or 15 minus 10. I still get the same 5, but one was positive, one was negative, right? Well, in net change, we'd like to know, are you changing in a positive manner? Are you increasing, or are you decreasing? And in this case, we want to be decreasing. So we've got to make sure that when we subtract these, our net change, which we said was delta y, I'm going to rewrite that as f of a plus h minus f of a. Okay, so that is my net change. So for our particular problem, remember that I had the function was 9 over x. Okay, I have to go back over here, 9 over x. Okay, so what I'm going to do is I'm going to evaluate these functions at 9 over x. Okay, so this point here at a, if I evaluate that function at a, it's now a comma 9 divided by a. Does that kind of make sense? Okay, we just take the x value and you evaluate it at the function. Now over here, okay, that point is going to be a plus h plugged into 9 over x. So I got 9 divided by a plus h. Okay, so I'm going to cut that out and use that instead. All right, so now when we look at those values when I'm doing a net change, now the net change is going to be that y value, okay, 9 over a plus h, that y value there, minus that y value, right? So writing that out for you would look like this. 9 evaluated at a plus h minus 9, come on, minus 9 over a. And that would be my delta y for my net change. Okay. Now we can also do some algebra to that, and this is what they wanted you to do in the homework. If I have 9 over a plus h minus 9 over a, okay, we can do algebra with that, right? We can combine those as long as I have a common denominator. Well, what's my common denominator going to be? A times a plus h, right? Okay, I need every component to show up at least once. Okay, so I just go ahead and write that common denominator out. Okay, now I think about how did I alter this denominator here, and then I have to alter. I don't know. How I altered this denominator, I need to alter that one in the same way. So multiply this one by a, so you're going to multiply the 9 by a. And over here, I multiplied by a plus h, so I'm going to multiply the 9 times a plus h. Okay. Now I'm going to distribute this negative 9 to this a plus h, so it gives me 9a minus 9a minus 9h all over a plus h. Would you guys agree with that? What happens with your 9a's? Cancel out, so you get negative 9h over a times a plus h. Okay. So I'll write that out. That is an equivalent format, and it's actually a better format than that one. Okay, so those are all equal, and I think that WebAssign is probably going to say this is wrong. They want you to go this far because of what we need to do in the next step. Okay, or what happens in the next step. They want you to go a little bit further with the simplifying. But what we just found there now is a formula that if I know what a is, if I know what that x value right there is, okay, if I know that x value, okay, and I know the distance between that x value and some other x value, so I know that distance, which is h. Would you guys agree with that? Okay, take a, add that to it. It should get me to this point here. If I know those two things, I can simply plug in to this formula and get the net change no matter where those 2 points are on my curve. Okay, we've just created a formula for net change for this specific function so that when I move a and h to those spots, I now have a formula based off of that number there and that h of what the net change is between those y values. Does that kind of make sense, everybody? Okay, and it makes things a lot easier if I want to look at the net change between a series of successive points, okay, I can do that relatively quickly now. Okay? But now, what's even better is not just being able to find the net change, but now to find the average rate of change. Well, the average rate of change is just your net change divided by the distance between your 2 points. Okay? Well, what's that distance between our 2 points here? H. Okay? So here's the logic, or here's the algebra that gets us to recognize that all we're doing is going to divide by that H. We know that average rate of change is equal to a fraction delta y that's a better delta delta y over delta x. Okay, so change in y over change in x, right? That is what our average rate of change is. Okay, so if we just had a formula now that asks us to find delta y, now all we have to do is find delta x. Well, delta x, same idea. Take your furthest point to the right, a plus h, and subtract from it the furthest point from the left. Okay, so delta x is going to equal a plus h minus a, right? Well, what does that equal? Just h, and that's what Chris told us, is that distance that we're coming across here is in fact h. That's what we need to divide by. Okay, so if I take this part here, okay, and divide by h, it will give me average rate of change. So let's do that. Let's go back over to this. Sorry that I keep jumping back and forth between stuff, but oh, not too far. This was a. That's a plus h. Okay, so that is my delta y, right? Okay, let's divide that by h. So if I divide that by h, it's going to look something like this, divided by h. Is that okay? Now if I divide that by h, that's still kind of ugly. I want to rewrite it as h over 1. Okay? Because when it's h over 1, you got a fraction now divided by a fraction, right? How do I do that algebra? Multiply by the reciprocal of that bottom. So I'm going to flip that, okay, and multiply by 1 over h, right? So I'm going to come up here, and I'm going to take this fraction, take its reciprocal. Oh, too far. Well. Okay, so now I'm going to multiply by 1 over h. And what is going to happen with that h right there and that h right there? They're going to cancel out. And that's going to give me a formula for average rate of change that says negative 9 over a times a plus h. And that's what they're looking for your average rate of change in that question. Okay? So paste that up here. Maybe not. Cuts. Paste it. So that is your average rate of change. And what's nice about that is that is now a formula that will actually give me that blue secant line slope no matter where A and H are. Does that make sense? And it allows us to find that slope kind of what we call instantaneously, regardless of where these 2 points show up. Okay? And here's the idea. Here's the reason why we want this to happen. In calculus, we want that H value to become very, 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 very small. We want the distance between the 2 points to be infinitely small. Okay? So we say that we're interested, if you look, I guess I erased it. We'll look at something like the limit of our average rate of change. So the limit of delta y over delta x as delta x becomes close to 0. Okay? Visually, what that means to us is that if we look at just this line right here, and we see we've been finding the slope of that line, because we find the slope of that secant, which is the same as the slope of that red line, right? But once I find these two values, a and a plus h, to be extremely close to one another, so the distance h becomes very, very small, okay, infinitely small, that secant line turns into a tangent line, okay? And if we can find the slope of that tangent line, we now know what the slope of this curve would be, 9 over x, if you were standing at that point on the curve. Does that make sense? Okay? But understand that that slope change, if I'm standing over here at a plus h right now, am I at a less steep slope than what somebody standing here would be at? Yeah, so that slope's going to change when we get over here, and we see that the slope of that line, that tangent line, is a lot less steep than it was over here. But it allows a formula for us to find the slope for a curve, because slope for a curve is not constant, but it is something that we're very interested in. So we have to have we developed a technique that allows us to do that. Okay. That way.